Hi, welcome to this video, and in this video we will discuss a hard question of overlapping sets. Let's read the question quickly. According to a survey, at least 70% of the people like apples, 75 bananas, and at least 80 like cherries. What's the minimum percentage of people who like all three? So clearly it's a question of three sets, so that's what I'm going to do. I will quickly make a three set Venn diagram. So here we have a diagram for the three. The question says that apple likers is greater than equal to 70 if the total is 100%, banana likers is greater than equal to 75, and cherry likers is greater than equal to 80. And the question is, what is the minimum percentage of people who like all three? If I say this x, then we have to find the minimum possible value of x. Now let's go slowly and try to understand what we need to do in this question. Understand that apple likers, this whole thing is 100, and this circle has the value minimum value 70. It is either 70 or greater, and x is the subset of this circle, which means if we want to minimize x, then we need to maximize everything outside this circle. I repeat once again. For example, what I mean to say is that this whole circle has a value minimum 70, either 70 or greater. If I say this is 70, then x will have some part of it. If I say this is greater than 70, then x may have a bigger part of it. For that reason, what I'm saying is, since x is the subset of a, so everything outside this set should be maximized, because if the summation is a constant, which is 100 here, and one thing needs to be minimized, then everything else should be maximized. So what I intend to do here is, I intend to maximize everything that goes outside this. So the maximum value that can go beyond this circle is 100 minus 70. So the maximum value outside can be 30, because the value here minimum is 70, so the maximum value outside is 30. Now what I'm doing here is, I'm putting this 30 here, and that's the iteration I'll be doing for you. Let's say 30 comes here, that means everything else becomes a 0, because the sum has to be maintained 100. Right? Now, similarly, this circle is 75 minimum. That means the value outside this maximum can be 25. Everything else is 0. And similarly, if I know that this circle has a value minimum 80, that means the value outside this maximum can be 100 minus 80, that is 20. I hope you understand where exactly are these values coming from. So 20 goes maximum outside this circle, and similarly 100 minus 75, 25 goes outside the circle of banana. Now with these calculations, let us see what is the value of x that I am getting. So I can say that summation of everything should be 100. So 25 plus 20 plus 30 plus x should be equal to 100. That means so far through this calculation, I've been able to arrive at a value of x which is equal to 100 minus all these values, which is equal to 25. So far looks like my answer is option C, which is the correct answer. Now I am quickly going to demonstrate the same thing by drawing another figure. Now some people may have a question, why did I maximize this region particularly? So that is exactly what I'm going to iterate here by distributing the value. So I will make the same diagram, just one change, so that you can understand what difference is that change bringing, right? I am still going by the same values, that the total value is 100, a has to be greater than equal to 70, b has to be greater than equal to 75, and c has to be greater than equal to 80. And we still have to minimize the value of x. Now I started with this calculation that a is 70 or greater, that means the value outside it is 30 or smaller. So the maximum value outside can be 30. Now this time what I'm doing is, I'm just breaking this 30 up as 27 and 3. Now let us see what change in the answer do I get if I just make this a small change here, right? Everything else will be 0 because the summation has to be kept 100. If I take the minimum value of the circle 70, then the maximum value outside will still be 30, and that 30 I have split between these two regions. So this is 27 and this is 3. I've assumed very random value. Just instead of keeping the whole 30 here, I'm just doing an iteration by splitting this 30 between two regions, so that we can see what change would it bring. Similarly, out of B, maximum value can be 25, so I'm keeping 25 where it is. Out of C, the maximum value has to be 20, but I already see 3 here. That means here the maximum value that can come is 17. Now let us see what the calculation brings. The summation of everything should be 100. That means 25 plus 17 plus 3 plus 27 plus x should be equal to 100, and that gives us x is equal to 28. Now do you understand? This is not minimum anymore. That's the reason why these particular regions should be maximized, while the value at the center, that means common to all, needs to be minimized because the summation is constant. I hope that makes sense, and now I have already proven that the answer is option C. Thank you so much.